Hi everyone, and welcome to WuShusMath. So today we're going to be talking about a very special type of triangle. So this triangle is not the normal triangle you see every day that looks like this, because this triangle is actually made of numbers. That's right, I mean numbers like 1, 2, and a million. Or a billion. So this triangle also has a special name. It is called Pascal's or Pascal's triangle. You guys might be wondering why it's called Pascal's triangle. Well, the reason why it's called Pascal's triangle is because it was invented by a man called Blaise Pascal. So, Blaise was a famous French mathematician that was actually born in the 1600s, which is about like 350 to 400 years ago. So that's pretty long ago. So this triangle he created follows a very special type of pattern. Is that if you go like, so this is the pattern for his triangle. And so on. So, because this pattern can actually go on forever, but when numbers get huge, it gets messy. So you guys might be wondering how I got the numbers in the middle, because you guys can probably see that all numbers down here are all ones, and down here. So you guys might be wondering, where did these numbers come from? Well, the way I got them is actually really simple. So all you have to do to find these numbers is by a process of addition. So as you can see, you see this 1, 1, and there's 1 something 1. Well, you take the two numbers on top of it, which is 1 and 1, and add them together. 1 plus 1 is 2. You keep doing that. 1 plus 2 is 3. 2 plus 1 is 3. Then 3 plus 3 is 6. 1 plus 3 is 4. 3 plus 1 is 4. Then 5, 10, 10, 5, 1. Then 6, 15, 20, 15, 6, 1. The next thing you guys are going to notice is that if I were to split this down the middle, this side is equal to this side, just that it's backwards. So, for example, let's take 1, 5, 10, 10, 5, 1. So it's 1, 5, 10, and that's just 10, 5, 1. It's just 1, 5, 10 backwards. So, you guys might be wondering why we even use Pascal's triangle. Well, one of the reasons why is that you can solve combinations. So, for example, you have 6 bowling balls, and you want to put them in groups of 2 to package. So it's 6 bowling balls, choose 2. So it's 6, choose 2. This can be solved using Pascal's triangle. So I'm just going to write this really quick just to make a quick note. 6, choose 2. You write down or draw Pascal's triangle. So you go down to the 6th row because it's 6, choose 2. So we count 1, 2, 3, 4, 5, 6. That is actually incorrect. The way you must count is actually you have to stop here. The reason why is because this 1 up here is not the first row. You actually have to count that 1 as a 0th row. Then it starts as first row, second row, third row, 4th row, 5th row, and then the 6th row is right here. Go to the 6th row and you count 2. So 1, 2. So if you have 6 bowling balls and you want to put them in groups of 2, the amount of ways possible is 15. If order does not matter, and the bowling balls can be used more than once for as many possible ways as possible. So one of the other reasons why actually is that you can use it to find powers of 11. So 11 sounds kind of random, but it's actually straight in Pascal's triangle. So I'll first write the few. And if you guys don't know, anything to the power of 0 is equal to 1. Equal to 1. So if you guys don't know this already, we've already created Pascal's triangle right here. And then the next number is a little bit different, which is the sixth row. The fifth row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1, which should equal to 11 to the power of 5. Well, you guys might think 11 to the power of 5 is just 1, 5, 1, 0, 1, 0, 5, 1. That is not the case. What you actually do requires you to do a little bit different. So you write 1, 5, and then because this is these two are double digits, you overlap. So it's 1, 5, and then 1 on the 5, 0, another double digit, overlap again, and then go on. 1, 1, 5, 1, 0, 1, 0, 5, 1. Add them together, you get 1, 5 plus 1 is 6, 0 plus 1 is 1, 0, 5, 1. So that is what 11 to the power of 5 is. So this will work for any row, including 1, 6, 15, 20, 15, 1. So there are a lot of cool ways you can do it, and one of the really cool things you can do with Pascal's triangle is you can also find out powers of 2. So, oops, I went too far there. I'll stop right here. So, you'll know that 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 squared is 4, 2 to the power of 3 is 8, and 2 to the power of 4 is equal to 16. Well, if you add these row by row, you do get 1, 2, 4, 8, and 16. So that's actually a really cool way you can do to find out powers of 2. The next thing that I will discuss really briefly is that there's a really cool little Easter egg inside Pascal's triangle. So what you do is that you take anything from this diagonal or this diagonal, but it must start at the one diagonal and go down as much as you want and then turn to the bottom left. So it creates a sock-like shape, and what you do is that if you add all these numbers together, 1, 2, 3, 4, you get 10. So this can work for anything. So 1 plus 3 is equal to 4. And then you can do 1 plus 1 plus 1 plus 1 plus 1 is equal to 5. And this also works this way. You just have to change the direction. So 1 plus 3 plus 6 is equal to 10. So I hope you guys found this video very helpful for you guys. And I will see you guys later.